Hello again. In this video, we deal with rational expressions, the second part of rational expressions. And here we talk about operations on rational expressions. What can we do with rational expressions? Can we add them, subtract them, multiply and divide, and so on? And here we will also, the operations we'll talk about are, like I said, addition and subtraction, multiplication and division. In this video, we only deal with multiplication and division. And in part 3, I will deal with addition and subtraction of rational expressions. When we deal with multiplication of and division of rational expressions, it's very similar to what we do with fractions, or what you have done before in fractions. And you need to recall how to multiply fractions. You remember that when you multiply fractions, you multiply across. So for example, 2/3 multiplied by 5/6. You multiply across as follows: 2 times 5 and 3 times 6. The result is 10 over 18, 10 divided by 18. And since 10 and 18 have common factors, that is different from 1, 2 is a common factor of 10 and 18, we can simplify and write in lowest terms. So if we divide 10 by 2 and divide 18 by 2, we will get 5 out of 9. And so we will say that 10 over 18 is 5 out of 9 in lowest terms. Another way of saying this is to say that 10 over 18 and 5 over 9 are equivalent fractions. They are the same fractions. If you simplify one, you can reduce one to get the other. And you can multiply the numerator and denominator of one to get the other one as well. So they are equivalent fractions. Also, you recall when you do division of fractions, what you do is that you would need to change the division sign to multiplication and then multiply by the reciprocal of the divisor. So your reciprocal here is 1/3. The reciprocal of 1/3 is 3 over 1. A reciprocal simply means, in layman's terms, to flip the fraction. In other words, invert the fraction. What was denominator before becomes numerator, and what was numerator before becomes denominator. So in this case, 5 halves divided by 1/3 is the same thing as 5 halves multiplied by 3 over 1. It then becomes a multiplication of fractions problem, and you can just multiply across like we did previously. Your result will be 15 halves, which if you like, you can write as 7.5. That will be called, you recall that that's called a mixed fraction. Now what we just talked about, we can apply to rational expressions as well. And we will demonstrate this with examples. So for instance, here are two rational expressions: d squared divided by 20 multiplied by 4a divided by 3d. We are going to multiply these. Like we said, we'll multiply across. So we would have 4a times d squared divided by 60d. 20 times 3 is 60. And if we simplify this, 4 is a common factor of 4 and 60. So 4 divided by 4 is 1. 60 divided by 4 is 15. And then you have d and d squared. D will divide itself once and it will divide into d squared. And you can take out one d. There's d left over there. So if you rewrite this, you will just have 1 times a times d. So you have ad divided by 15 times 1, which is 15. And if you go back to the initial expression, we have d squared over 20 times 4a over 3d. You can see in your denominator there 3d. D cannot be, right? D cannot be 0. It's a non-permissible value. D can't be 0, because if d is 0, you are going to be dividing by 0, which we had said is criminal. Then let's do another example. 4x times x plus 3 divided by 3 times x minus 1 multiplied by 5 times x minus 1 divided by 2x. So we're multiplying these two rational expressions together. You can see that these are in factored form already, right? So there is there's no need to factor it because it's already in factored form. If it was given to us in a non-factored form, then we would have to factor it. So what we'll do here is to simply multiply across. We'll get 20x times x plus 3 divided by x minus 1 divided by 6x times x minus 1. And our restrictions here, our non-permissible values are 0 and 1, because if x is 0 or 1, the denominator is going to be 0. And then we can simplify this by taking out the common factors. X minus 1 is a common factor of the numerator and denominator. There is 1 each. We can take those out. And similarly, x is a common factor. We can take those out. And if we divide 20 by 2 and 6 by 2, you will get 10 over 3. And then our result we can rewrite as 10 times 1 times x plus 3 times 1. You get 10 times x plus 3 divided by 3. And your restriction is still 0 and 1. So that is the final result there. It is in lowest terms. So that is about multiplication of rational expressions. What about division of rational expressions? I illustrate with examples as well. Here you have 5n squared divided by negative 2, or divided by 5n over 6. So 5n squared over negative 2 divided by 5n over 6. Again, like you would do with real numbers, you have to rewrite the expression and change the division sign to a multiplication and multiply by the reciprocal of the divisor. Your divisor here is 5n over 6. The reciprocal is 6 divided by 5n. And then it becomes a multiplication problem, and we can simply multiply across as follows: 6 times 5 times n squared divided by negative 2 times 5 times n. And we know that from what we've talked about so far, our non-permissible value here, our restriction, n cannot be equal to 0. We can then simplify by dividing by 2 in the denominator and numerator, and 5 is common to the numerator and denominator. N is also common to the numerator and denominator. Our final result there will be 3n divided by negative 1, which is the same thing as negative 3n, with a restriction of n cannot be 0. Let's do one more example. We have 6x minus 4 divided by 15x minus 10 over 9. Now, the first thing to do here is to simplify by factoring, right, the numerator and the denominator in where the algebraic expressions appear. Now, if we do that, for your numerator, 6x minus 4 is the same thing as 2 times 3x minus 2. And in the other, for the divisor, 15x minus 10 is the same thing as 5 times 3x minus 2. And then we can change the division sign to a multiplication, and it becomes a multiplication problem. Our restriction here is 2/3. When x is 2/3, your divisor will become 0, and you can't have that. Then we can rewrite by multiplying across, and then we can take out the common factors. Our result will be 2/5 with a restriction of 2/3. So you go ahead now and try this example like we have done previously. Please pause the video now and try this example, and then when you're done, you can continue the video to see what I have done. So please pause the video now. So what did you do? Well, here is what I did. For the first one, the common factors here are m for the numerator and denominator, and you can see 4 can divide into 8, and q can divide q squared. Your result there will be as shown, 2q over 5. Your restriction is q and m cannot be equal to 0. And for the second one, we have to factor the numerator and denominator for the first expression. If you do that, you will have 2 times a plus b divided by 3 times a minus b. And for the second factor that you are multiplying by, a minus b divided by a plus b, there's nothing to factor. So the common factors then can divide out, and our result is 2/3. Our restrictions are such that a cannot be equal to b, and a cannot be equal to negative b as well. And thirdly, we are dividing 4m plus 16 over 10 divided by 3m plus 12 over 18. Like we said previously, we'll have to factor where appropriate, and then we'll have to change the division sign to multiplication, and then our divisor will have to invert and write its reciprocal as shown. So if we factor this now, we will have 4 times m plus 4 divided by 10 multiplied by 18 divided by 3 times m plus 4. M plus 4 is a common factor. We can divide that out, and we can see that there are other factors there as well. You can see that 3 can divide into 18 and 2 can divide into 4 and 10. Your final result there will be 12 over 5, and your restriction is minus 4. So that concludes the second part of rational expressions. In the next video, we will talk about addition and subtraction of rational expressions.